r cis theta all raised to the power of n was just r to the power of n cis n times theta. It was, when we did it yesterday, it was quite easy, wasn't it?
Yes.
So we had an example of 2 cis 45 to the power of 5. We raised the 2 to the power of 5 and then just went 5 times 45 and got an answer. And I said to you guys, remember this part here should be written as negative 135. Why is that? Because there's pi and negative pi, 180 and negative 180. Okay, make sure you remember that. So what we're going to do now is just have a little quick introduction about how to trying to use it, and then we're going to try and solve some stuff with it. Okay, that's what you're going to try and do. And if we can finish that this week, then that's great. So here's an example. Use to expand. So how are we going to expand that? No, that is year 11 type incorrect expansion of stuff.
Oh, really?
Yeah, it is. That's the binomial theorem. Would have to do like 1 times 3 to the power of 6 plus 6 times 3 to the power of 5 I to the power of 1 and keep going. How do we do that? Convert it to polar form. So 3 plus I is the same as 3 squared plus 1 squared. Square root of that. That's root 10, is it not?
Yes.
Yeah?
Yes.
Theta is negative sine of 1 over root 10. And theta is the arc cosine of 3 over root 10. What are those answers, please? Now this is going to be the same as root 10 cis. So that is 18 point what?
Stop being so selfish, Richard. Are you joking? Are you actually joking on grammar?
Just shush. Let's just leave him to do whatever he needs to do, okay?
He's recording a video. Let's just
There's that. Are you guys happy with that?
Yeah.
Okay, so now how do I expand it? What do I get? I get
root 10
root
cis.
power of 6.
Oh, okay. And then
Power of 6,
yeah,
which is root 10 to the power of 6. Cis 6 times 18 points. Now what is root 10 to the power of 6? 1,000? 6 times 18 is
112.4.
6 times 18.4. I just don't trust that, to be fair.
No, but
It's quite correct that I shouldn't trust you either. There's my answer. Well, to be fair, what I should have done is had that answer times 6, which is 110.6. Why should it have been 110.6? Because it's not 18.4, it's 18.4349. Because I am now year 13, I probably should have that on my calculator. So there's the answer. Does that make sense? Is that a tricky process? Rectangular form to polar form and then expand. It should be relatively straightforward, eh? Okay? And then there's a harder example. I might as well do this one now. How would you do it with that one?
same.
Exactly the same. So the modulus of this one is going to be root 2. The argument is going to be 3 pi over 4. So this is root 2 cis 3 pi over 4. Who knows why I know that? It's not isosceles triangle. 1 to 1. 1, 1. 1 squared plus 1 squared is 2. Root 2 is the argument. Yep. Isosceles triangle. Real part. So if I drew it on my Argand diagram, it should be up there. Hence why it should be 3 pi over 4. So it's all that to the power of 1/3. So how do I do it now?
Times root 2. I mean,
Root 2
to the third.
to the power of a third, cis a third times 3 pi over 4. Now that is just going to be the 6th root of 2, cis pi over 4. That should be your answer. Did I lose anyone anywhere with that explanation?
How do you get like exactly 3 pi over 4? Like, does it calculate it, get it out? Or?
Yeah. Yeah.
But my calculated.
Calculator, your calculator would have given you 135.
Oh, I see that. Okay.
Yeah, so 135 is 3 pi. Any questions with that? Straightforward?
Yeah.
If you can understand that, and you can understand this one, that's where I want to get to by the end of today. Okay? And it should be pretty straightforward, really.